Hello everyone, my name is Benjamin Depardon and I'm the CTO at UCit and also one of the co-founder of the Do It Now company. Today I'll be talking about how we can make HPC flexible, and I will be presenting that through a few projects that we've had, either with clients or through research projects. So very quickly, first, who are we? So UCit is a French company based in Montpellier, south of France. And what we do is that we try to apply data science to the HPC world to try to better understand what has happened on the HPC platforms, how to improve them, how to make decisions, and where the different workloads should be executed based on their requirements. We are also, as I said, one of the co-founder of Do It Now, one of the sponsors of this event, HPC KP, and so I will be coming back on that at the very end of my presentation. So why and what type of flexibility here are we talking about? HPC has been rising since many years now, and since the beginning, the core of HPC was the on-premises HPC cluster, where you run large simulations, complicated simulations with dedicated hardware to do so. But more and more, what we see is that many different new use cases arise that can be difficult to handle with traditional HPC resources, or at least with the on-premises clusters that people have. And so what I'll be doing today, as I said, is I will be presenting a few use cases that we've had and how we implemented some kind of flexibility at different levels. So of course we'll be talking about cloud computing, we'll be talking about also edge computing, but also in terms of how do we handle this flexibility, how do we do the selection between the different possibilities that we have, and how to mix different types of workloads as well on the platforms that we can address. So first of all, one use case, which is maybe the most common that you can see and very well related to cloud computing, is how do I handle specific demands or peak demands sometimes on my platform. And here I have selected two use cases that are a bit different in terms of what they needed, but that has been solved with the same type of hardware of a solution in the end. So first of all, Storengy. So Storengy is an oil and gas company in France. Basically what they do is that they store gas underground to release it when there is demand from the consumers. And so they do a lot of simulations to understand how these wells work. And so they have an on-premise cluster, which is quite well loaded throughout the year, but sometimes they have a specific demand that they call a data room, which is basically they have only 2 weeks to process quite a lot of data to decide whether or not they will be investing millions and millions of euros in a new well. And so this takes precedence over everything else that is currently going on the cluster that they have. And as you can imagine, this has a huge impact on the rest of the R&D and of course also on the production that they do on their cluster. And so what they did is that we identified with them a specific workload which was mainly responsible for the whole load of the cluster. And it's not a traditional HPC as you would find on some very large clusters. It's a combination of MATLAB and some internal MPI code that they have, which has some specificities more in terms of I/O patterns that they needed to support, with very strong requirements on that to have the simulations that are as interactive as possible for the end user. On the other side, the second example I have here of specific demands is the Surfax in France, who is a computing center, a research center dealing with many different types of simulations. And one thing that they also do is that they deliver training frequently during the year on CFD mainly, but not only, so different types of applications. And the problem that they had, and this was particularly true this last year, was that it's difficult for them to open accounts on their HPC cluster and difficult to open remote access to their HPC cluster for their to deliver their training. So it's always a few days of preparation for the administrators and for the whole organization to be able to do that. And so what they needed to do during the COVID-19, of course, was that they needed to deliver them online so that people from anywhere could use follow the training, but not on their HPC cluster, because this was restricted for external users. And so what we have delivered in post-project was to use the cloud to deploy on demand, whenever that was needed, new HPC clusters to sustain this specific activity. And so this has been done with a tool that we have developed, which is called CCME, which is built around AWS Parallel Cluster, and basically which creates a traditional HPC cluster, but in the cloud. The flexibility here that they gained was that they could deploy such clusters very quickly. In less than 30 minutes, they can pop up this new cluster with specific resources, adaptable in terms of the number of resources, the type of resources, also the type of file system that they want to use, depending on the I/O patterns that they want to sustain. So, for example, for storage, it was BGFS that was the most relevant for the type of workload that they have. And for the Surfax, they just need to pop up this cluster, and then automatically it generates new user accounts that are destroyed at the end of the training, and so they can just deliver the training online with this cluster. Another example, which is a bit more hybrid than the previous one, is a research project which is called AQMO, for air quality and mobility. So this was a European project that we were involved with the 10 of partners that you see here at the bottom. And the idea here was to build an end-to-end platform that on one side gathered some information about the air quality in a city in France with newly built sensors that were deployed on buses. And so when buses would drive through the town, they would gather some air quality metrics, and as they have many buses, it will map quite correctly the whole city. So we have some sensors that gather some information here on the buses level, and we need then to process this data to be able to take out any relevant information that is present in this data, and also to do some predictions on how the air quality will evolve in the coming days or weeks to be able to make decisions in terms of investment, for example, for the city. And in this case, what we have is that we have deployed a solution which is really from edge to cloud, in the sense that on all the buses there are the sensors that are present, but there is also a piece of software that is here to be able to do part of the processing of the whole workflow, so to pre-process the data, extract relevant information, hide some information. So, for example, hide the face of people, hide the license plates of the cars, because there was a camera also with the sensors. Then there was some kind of centralized platform where all the data was gathered and where the post-processing could carry on with a bit more computing power. And then when real simulations were needed, then they could be run on either a supercomputer or in the cloud. And so for that, we use some of the tools that are shown here on the right, where Rayax, which is a workflow manager built on top of Kubernetes, manage this whole execution, definition and execution of the whole processing workflow from end to end. We had some tools that were able to deploy the clusters in the cloud whenever required, so with CCME. But of course, when you have multiple places where you do your computation, you need to have a decision on that. And so we built also during the course of the project a decision tool that would select the best target platform based on the type of simulation you want to run, based on the load of the current resources, the current cluster that you want to reach, and also try to predict the time to result for each simulation based on the parameters, the input data, etc., etc. So here, the flexibility is how do we handle these computations really at different levels to process the data, and how do we start to make decisions on how and where we will do these computations. Finally, another project that I would like to share with you, and this is also a research project financed by the European Union, which has just started a few months ago, which is called HEROES, for Hybrid Eco-Responsible Optimized European Solution. And here the idea is to develop this. It's a short project, it's only a 2 years project, but the idea is to develop a software platform that will allow, on one side, HPC resources or cloud providers to deliver some computing power to end users. For some people to package some applications and workflows and also publish them to end users. And on the other side, engineers and researchers to be able to use those workflows and to do the processing they need for their research, for their work, in a transparent way on the different platforms that are available. And this type of simulations could be either traditional HPC simulations, but we also want to include machine learning AI workflows also within the project. And one part which is very important also in the project is that as we are striving to interconnect these different types of resources, cloud, on-premise, HPC cluster, we need to have a very strong decision tool at the core of the project to take into account not only the performances of the simulations and the AI workflows we want to run, but also to take into account the cost that it will incur to do so, because the idea is that end users will pay for what they use in the end. And one consideration which is also growing more and more, and which is of course very important, is the fact that of course HPC is good, it's all about performance, you need to do so to deal with very large problems, but you need to do it the right way so that you do not use resources that would consume too much energy and would have a very large impact on the environment, for example. And so for that, we have incorporated into the project a tool which is called here Energy Aware Runtime, which is a tool that tries to optimize the energy consumption of the jobs while they're running, to decrease the frequency of the processes, to lower the impact of each job while keeping the same performances for the job. And so the project is still very early stage, but these are some of the tools that we plan to use within the project. So it is hybrid, it is flexible in the sense, as I said, that we will have multiple HPC resources, be they on the cloud. So we are targeting first AWS and OCI, different HPC centers with the different partners that we have and that will be involved in the project. We'll support many different types of job schedulers, starting with Slurm and OpenPBS. Workflows will be managed by React and Kubernetes as well. We will try to abstract what is present in the different infrastructure with containers, of course, and we'll be using Singularity. And one point that is also important for the project is how do we move data around? How do we keep track of where data is in order to optimize the different data movements? And so we'll be using, at least for part of this, MinIO and rclone for this project. Okay, so these were just a few examples of projects on which we've been involved and where we see that flexibility can be and must be at different levels because it opens new use cases, new capabilities for end users to do HPC. Some of the key aspects when we want to do so, when we want to add flexibility, is of course to identify the different workloads that we need to move to one place or the other. We need to take into account data, of course. It is central. It is the key to be able to add this flexibility. But not only the computational part, we also need to take into account the user, where he is and how he's working, his whole workstation, for example, what is the process that he is using. And so all in all, this flexibility is great, but it might add some complexity, of course, in terms of administration or usage. And we need tools to do to help this whole transformation and to make the right decisions on, as I showed, on the energy, time, and cost space that we, depending on what we want to optimize and take into account, of course. And one last point, of course, is that even if we take cost into the decisions, we also need to make sure that the whole tool, the whole solution doesn't cost too much. Otherwise, it would kill the flexibility that we are trying to achieve. Okay, and just so for my last slide, as I said, we are one of the co-founders of the Do It Now company, which is one of the proud sponsors of this HPC KP event. And so I just wanted to briefly introduce you who we are and what we do. And so Do It Now has been created in 2020 and by the three companies that you see here. So as UCit and our two partners, HPC Now in Spain and Do It Systems in Italy. And what we do, why did we create Do It Now? The idea was to be able to regroup all the capabilities that we have in our three companies behind a single entity that would be able to deliver HPC services around Europe with all the necessary skills and HPC level that are needed. So we're still independent companies, but Do It Now is now a new actor on this market. All in all, we are more than 80 highly skilled HPC engineers that can be leveraged through projects through Do It Now, and we are still actively hiring. So if you want to join us, please feel free to contact us. Thank you, everyone. Thank you, HPC KP, for the invitation. And if you have questions, let me know.